Okay, in this we're going to be talking about real and complex roots. Remember, complex roots are anything that are imaginary. Okay, so find the roots of each equation for each of the following quadratic functions by solving for x when y equals 0. So anytime you're trying to find the roots or find the solutions, we're going to change y to 0. And then we're going to solve it. Okay, so when I do this, I am not going to write this out twice. It's already got one x, so we're just going to solve for x. So I'm going to subtract 9. Opposite of squaring is square rooting. My answer is going to have plus or minus in it because we're solving. That set cancels, so it becomes x plus 5. Okay, I don't like negatives in here, so we're going to change it to an I because now I can simplify that to a 3. And then we're going to go ahead and subtract this 5. So it stays a negative 5 plus or minus that 3i. So that means I have two complex answers. Okay. Do either of the functions intersect the x-axis? We don't know how to graph imaginaries. Okay, so no, they wouldn't because they're complex answers. What do you notice about the complex solutions for problem 1? Describe any patterns you see or observe. Okay, so potential pattern. We flipped this sign and then we square rooted that 9. So there's one potential pattern that you could observe. Okay, my next, find the sum and the product of each pair. Look for patterns as you calculate. So sum work. So I'm doing 2 plus I plus 2 minus I. This one I'm doing 3 minus 5I plus 3 plus 5I. 4 plus I plus negative 4 minus I, and then we have 1 plus I square root 3 plus 1 minus I square root 3. Okay, so we're going to go ahead and add them. 2 plus 2 gets me 4. My i's cancel because one's positive, one negative. Okay, my next one, 3 plus 3 gets me 6. My i's cancel because one's positive, one negative, same thing. Negative 4 plus negative 4 gets me negative 8. I's cancel because they're the same thing but one positive, one negative. 1 plus 1 gets me 2. These are the same, one positive, one negative, so they cancel. Okay, my next set, we multiply them. So I'm doing 2 plus I times 2 minus I. This one I'm doing 3 minus 5I times 3 plus 5I. Negative 4 plus I times negative 4 minus I. And then my last set, 1 plus I square root 3. 1 minus I square root 3. So we're going to either FOIL or box it up or distribute for all these. So if I do my 2 plus I, 2 minus I, my first is 2 times 2, which gets me 4. Outside is going to be negative 2I. Inside is going to be positive 2I. And my last is going to be negative I squared. I squared changes to negative 1. My center cancels, so it will change it to a plus 1. So when I add it, we get 5. Okay, my next FOIL here, 3 times 3 gets me 9. My outside gets me 15I. My inside gets me negative 15I. And my last gets me negative 25I squared. Okay, negative 25I squared will change to a plus 25 because that I squared. And then my center will cancel. So really we're doing 9 plus 25, which is going to be 34. My next one I get positive 16 plus 4I minus 4I minus I squared. That I squared is going to change it to a plus 1, and my center is going to cancel. So it really becomes 16 plus 1, which is 17. Okay, my last one, this one is hard, so 1 times 1 is 1. Outside 1 times negative I square root 3 is negative I square root 3. My inside is a positive I square root 3. And my last, negative I times I gets me negative I squared. 3 times 3 gets me 9. Center cancels. I squared changes to a positive 1, so it's going to flip the sign, and the square root of 9 is 3. So it really becomes 1 plus 3, which will get me 4. Okay, what complex number can you multiply 3 plus 2i to get a 9? Okay, so imaginaries always come in pairs. Remember that, okay? So we want to do its complex conjugate is going to be that 3 minus 2i. Okay, create a quadratic equation for each pair of the complex numbers in the table from 4 so that we can make our equation. So if I was doing, I'm going to show you the long way and then I'm going to show you the shortcut. So my long way, there's always a minus sign and then I'm going to put these in parentheses when I plop them in. Okay, so 2 plus I in parentheses. Because that negative is going to have to distribute to both of them. And then I have another x minus, and this one we're doing the other set, so 2 minus I. Okay, so we're going to distribute the negative to both of those, so it's going to become x minus 2 minus I and x minus 2 plus I. The thing that sucks about these is now we have to distribute, so it's an extremely long process. Okay, so x times x gets me x squared. X times negative 2 is negative 2x. X times I is xi. Now we got to do our next rainbow set. Negative 2 times x is negative 2x. Negative 2 times negative 2 is positive 4. Negative 2 times I is negative 2i. Now I got to distribute my last one. So negative I times x is negative ix. Negative I times negative 2 is positive 2i. And then negative I times I is negative I squared. We're going to combine like terms, so there's no other x squared, so he just chills down here. Negative 2x minus 2x is negative 4x. Xi and negative xi cancel because they're the same but opposites. Okay, then we have 4, which doesn't have anything else to pair with. And then my last stuff here, negative 2i, positive 2i, same thing, but they cancel. And then my I squared changes to a negative 1, so plus 1. So x squared minus 4x plus 5. And then we want it to say y equals so that we can graph it if we need to. Okay, so there is my long route. Then we have a short route. So that's the answer that I should get. Oops. X squared minus 4x plus 5. Okay, so I'm going to erase all this and show the shortcut this time. Okay, so we could figure out what adds to get you a number and what multiplies. So adding, I take 2 plus I plus 2 minus I. Multiplication, I multiply them. So 2 plus I times 2 minus I. So this one's pretty easy. 2 plus 2 gets me 4, and my i's cancel. When I FOIL, I get 2 times 2 is 4. That's negative 2i, positive 2i, negative I squared. My center cancels. I squared becomes a negative 1, so it just changes to a plus 1, which is 5. Okay, this will be my inside one, and you always flip the sign. This will be my last one. Don't flip the sign. So whatever adds gets you your center when you flip it. Whatever multiplies gets you your end number. So there's the shortcut that you can use. And in the table here, we did what added and multiplied. So your next 3 questions, this is going to be your center, that's going to be your end. But always flip this one. Okay, this is going to be your center, that's going to be your end. Flip that answer. Flip that answer. Center, end. Okay, for each pair of numbers below, find a possible quadratic equation that has these numbers as solutions. Okay, so we're first going to write them in their minus signs. So I plop them in, there's always a minus sign in front. Okay, I want to change this minus sign to plus because 2 negatives make a positive, and then I don't like fractions. So before when we were factoring, we would bring our bottom forward. So I now have y equals 4x minus 3 times x plus 5. Okay, to solve this, I want it in standard form, so we're just going to FOIL this or box it up, depending on which one you like best. Okay, so 4 times x gets me 4x squared. My outside gets me 20x. My inside gets me negative 3x, and my last gets me negative 15. Combine my inner terms, so the answer I'm going to be looking for is 17x in there, minus. So always put the minus sign, plop them in. Okay, my next one, I got positive 3i, negative 3i, so I can use my shortcut if I want to. So I have my addition and my multiplication. So 3i plus negative 3i is 0. And then when I multiply, 3 times negative 3 gets me negative 9. I times I is I squared. which will change it to a positive 9. So when I write it out, I got 0x plus 9, or just x squared plus 9, because 0 times x is just 0. Okay, based on the following graphs, how many real roots does each polynomial function have? Okay, so real roots are anytime it crosses my x-axis, so we have 2 real roots in this, and an x squared graph. So if we think back, x squared means that 2 tells me how many answers I should have or how many solutions. So I should have 2. Okay, this one is an x cubed graph. So I should technically have 3 answers, but not all of them might be real. But I do have 3 real answers in this one. Okay, I have another x squared graph, but I don't cross my x-axis, so I have no real solutions. Here's my x cubed graph, so I technically should have 3 answers, but I only cross once, so I have 1 real solution. Okay, do the polynomials in 10 have fewer roots than those in 9? So if I look, if I match my 10 and my 9, they should have the exact same amount of solutions. The only difference is these ones have complex answers. I should have 2 solutions. There aren't any real, so that means I have 2 complex in this one, and I have 2 complex in this one, because I should have 3 answers, and I'm only showing 1 real one. Okay, so do the polynomials in 10 have fewer roots? No. Okay, they just have complex ones that we can't see. How are the roots in C different than the roots in A? There was the 2 complex in both of those. Okay, now consider the graph. How many real solutions could this have? So that 3 tells me I have 3 potential real solutions. And then what we're going to do is see if it's true. So this, we want to show that it represents the same thing. So I have x minus 2 times x squared minus x plus 1. So if I factored it, so we're just going to double check to make sure that that was a good factor there. So x times x is x cubed, x times negative x is negative x squared, x times 1 is x, negative 2 times x squared is negative 2x squared, negative 2 times negative x is 2x, negative 2 times 1 is negative 2. So I get x squared minus 3x squared plus 3x minus 2. Okay, so that was a good factor. Okay, so my next step, I want to figure out what the actual roots are of that. So I'm going to go back. I have x minus 2 times x squared minus x plus 1. So we're going to find the actual roots. So to do that, we set it equal to 0. Once we have it in our sets of parentheses where it's factored, we can do ZPP. So I have x minus 2 equals 0. And I have x squared minus x plus 1 equals 0. So this one's pretty easy to solve. We add 2, we get x equals 2. My next one, we got to factor again. So we have to check to see, 1, do I have a number to send back in front of x squared? I don't. So then I see what multiplies to 1 adds to negative 1. There isn't anything. So now I go to quadratic formula. So once you can't factor it, you have to use quadratic formula. So a is 1, b is negative 1, and c is 1. So I'm just going to plug it in real quick. Negative 1 and for a negative b becomes a positive. Okay, we are going to simplify in my square root. Negative 1 squared gets me 1. Negative 4 times 1 is negative 4. 2 times 1 on the bottom is 2. 1 minus 4 is negative 3. I want to get rid of that negative by taking an I out. And then I can't simplify anything anymore. So there are 2 answers. We have the positive side of it and the negative side of it. So 1 plus I square root 3 over 2 and 1 minus I square root 3 over 2. And we have x equals 2. How many answers should I have? I should have 3, and that is what I got. So if it was x to the 4th, I should have 4 answers. If it was x to the 5th, I should have 5 answers. Okay, so 2 of these were complex. Okay, so we had 2 complex right here, and then we had 1 real. All right, make a sketch of the graph with the indicated number of solutions. Okay, so first off, we are going to find our degree. Then we are going to find out how many turning points I have. And then we're going to find out how many real solutions that cross the x-axis. Okay, so I'm going to write degree, turning points, real solutions. Degree, turning points, real solutions. Degree, turning points, real solutions. Okay, so the degree is the total that I have. So this one is 5. This one is 5 because I should have 5 answers. This one is 4 because I should have 4 answers. This one is 6 because I should have 6 answers. Okay, turning points, I take my degree, I subtract 1. So that means this should have 4 humps. This should have 4 humps. This should have 5 humps. This should have 3 humps. Real solutions is how many times it crosses my x-axis. This one should have 5 times. This one should cross 3 times on my x-axis. This one should cross 2 times on my x-axis. And this one will cross no times on my x-axis. Okay, so this one, I'm going to start with my real solution. So I should have 1, 2, 3, 4, 5 times where it crosses. Okay, I should have 4 turning points. So I'm going to start. There's 1, 2, 3, 4 turning points, and then I'm going to continue my arrows. 1, 2, 3, 4 turning points. My next one, I should have 4 turning points. I cross 3 times. So if I start 1, 2, 3, I still need another turning point, and I cannot cross my axis. So I'm just going to make another hump and continue my arrow away from my axis. You don't want to turn it back up to your axis because then if your arrow is going up, it's going to cross your real axis, and we can't have another one crossing. And it has 1, 2, 3, 4 humps or 4 turning points. Okay, my next one, I don't cross my axis at all, so I'm just going to go ahead and start. I want my arrow to start pointing away because if it points towards my reel, that means it would cross it, and I need 3 humps. So 1, 2, 3, point my arrow away, so that it's not eventually going to cross my real axis. So 1 hump, 2 hump, 3 humps. Okay, this one we are crossing twice, and then we're going to have to turn 5 times. Okay, so we're going to get our 1 hump, 2 hump, 3 hump, 4 hump, 5 hump. Keep it continuing it away so that it's not crossing your real axis. So 1 hump, 2, 3, 4, 5 turning points.